Here we can see the MOSFET structure. This is the piece type substrate, which is called as bulk, or it's also known as body, which is doped with boron impurity, which acts as the acceptor impurity. And these are the two N plus regions, or the N type well, and the plus sign indicates that it is heavily doped with the donor impurity atoms, for example phosphorus or arsenic. Between the N plus and the P type bulk, there is a formation of PN junction diode, and the P type substrate is connected to ground, so that the PN junction diode which is formed is reverse biased. It is formed in this PN region, and also here the PN junction diode is formed, which is reverse biased. The p-type substrate is lightly doped, and the region between the two n plus regions is the channel, which is represented by the letter L, and which is equal to 2 times lambda. Lambda here refers to the feature size, which is half the minimum gate length or the gate width. This is the source electrode, gate electrode, drain electrode. The gate electrode acts as the control electrode, for which if an electric field is applied, it influences the channel formation, or it influences the formation of the channel and the movement of the charge carriers in the channel. This is known as the polysilicon, which is the gate, and it is heavily doped. The polysilicon is heavily doped, the source well is heavily doped, the drain well is heavily doped. The thin oxide is SiO2, silicon dioxide. It is known as thin ox since it is very thin. The very thin SiO2 is used here. The thin ox helps in influencing the channel by the gate voltage applied to the gate electrode or the control electrode. This is the FOX, that is field oxide. The field oxide is surrounding the either side of the N plus, which is as we can see here, and either side of the polysilicon, that is the gate that we can see here, and on the either side of the drain, as we can see here. The field oxide helps in insulating the device or isolating the device from other devices, other adjacent devices, or to provide the electrical isolation between the adjacent devices on the chip.